Let's look at an example from the homework for using the midpoint rule and the trapezoid rule. Several of these ask you to do more than one of these approximations, and the reason is that they're trying to show you how the error is improved when you double the number of subintervals. So we're not worried too much about the the error bounds in our abbreviated treatment of this. So really, all I want you to know is how do you use the geometry of the situation to find the actual approximation. So let's just do the middle one of these. 2 subintervals seems fine for the midpoint rule. It also asks you to do it with 1 subinterval, which is very straightforward, and 4, which takes a little more time. But it really will help to have a picture, even if it's just a very rough sketch. The function here is y equals 2x squared, so we know that's a parabola, so it's going to go up like that. The scale is going to be crazy different on the y-axis here because it's getting really big really quick, but I want to be able to draw on it, so I'll draw it like this. And we're integrating from 5 to 12, so let me just say that's 5 and that's 12, just to keep it on the screen. And so this would be the area that's involved here for this integral. Now, if I'm doing 2 midpoint rectangles, well, I'll go ahead and do 4 just to make the point. But if I'm going to do 4 midpoint rectangles, that means I need to, 5 to 17, sorry. I shouldn't try to do this first thing in the morning. You can't even see the screen. 5 to 17, sorry about that. I first need to break my picture up into the correct number of strips. So if I'm doing M4, that means I'm going to have 4 strips. The width of the whole interval here is 12, 17 minus 5. And so if I break that into 4 strips, that means I will broken into strips of size 3. So if I want to mark that, I'll have, well, I'll use black. So there's the center between 5 and 17, center that, and those are 3 units apart. So this is 8, this is 14, and so on. I guess not and so on, there's only one more. I can write down 11. So those are the numbers that I have where the strips are drawn. Now for the midpoint rule, those numbers are not really relevant, because that's not, I don't care what the function does at that point. The midpoint rule, let me just erase these. The midpoint rule says for each of those subintervals, draw a dash, mark the midpoint of the subinterval. So that's why it's called the midpoint rule. You're marking the midpoints of those subintervals. So now the values of these are relevant. So that's halfway between 5 and 8. So that means that is 6.5. This value is halfway between 14 and 17. So that's 15.5. This value will be 9.5. And this value will be 12.5. So I should have even had a more exaggerated scale for this picture, and it would have been a lot easier to draw. But those blue tick marks, those are relevant because the top of the rectangles I'm going to draw are going to be right above those values. So here are the positions of the heights of the rectangles I'm going to draw. So I'm going to put a cap on top of each of these strips, and some of them have to go up a little further on one side. But the height of each of those rectangles is dictated by the dot on the curve above the blue numbers I just wrote down. So if I have that geometry correct, I have everything labeled right, I'm literally, for the midpoint approximation, just doing base times height for each one of those rectangles. Now, each of those rectangles is 3 units wide. And there are 4 of them. So what I need are the heights of the four rectangles. So the rectangle number 1, its height is the value, the y coordinate of that dot, because that's how high that point is above the x-axis. The y coordinate of that dot is just found by plugging in 6.5 into the formula for the curve. So the height of the curve, sorry, the height of the first rectangle is f of 6.5. The height of the second one is f of 9.5. So you can see that the most important thing is to be able to draw the picture and label on the x-axis the values above which you're going to be using for the heights of your rectangles. Once you have that, then it's really just doing base times height for four rectangles. Keep in mind when I say f here, the function f is the thing that was being integrated. So in this case, those all come out to be nice whole numbers when you square. Does it? Do they? No, maybe they don't. Well, I think they each come out to be something with a half, but then when you add them all together, it's a whole number. So it's a fairly big number, and you can use the actual integral from 5 to 17 of 2x squared. That's an easy question to get the exact answer for, to see that the midpoint rule does get you in the ballpark of the right answer for that. Why does this have a black background? All right, well, here we have the function 2x cubed, so it's going to be a similar picture. And again, I'm going to exaggerate the scale as much as I can, integrating from 4 to 12. So the area that I'm looking for looks like this, and my function is 2x cubed. So let's do 4 again. 8 is a bit much, honestly, but 4 is not too bad. By the way, for any of these that have a large number, just Google like trapezoid rule calculator. If you can do the ones that you can draw easily, then that's fine. You're not going to be assessed on anything else. There are about 5,000 websites that have little trapezoid rule calculators or midpoint rule calculators that just do this geometry summing calculation. And so for the ones with larger subintervals, definitely do that. And on this one, if you can do the one for 2 and 4, drawing the picture and understand it, then there's really no reason to drag yourself through all of the arithmetic to doing it with 8. It's not harder, it just takes longer. So I would just Google trapezoid rule calculator and put this problem in with 8 subintervals to get that answer. But do make sure you can draw the picture for the smaller cases. So let's do T4. And so recall we have to use the area formula for a trapezoid. So if I can draw it correctly, a trapezoid just has 2 parallel sides. That's what makes it a trapezoid. It's a quadrilateral with 2 parallel sides. And when you have a trapezoid, ours will always be oriented like this, where we can think about the 2 sides as being heights, the 2 parallel sides as being heights, and then the distance between them as being a base. If you studied trapezoids in a geometry class, they probably weren't always drawn that way, but ours will always come out that way, so it's a fair way to think about the area formula. And when you have that, then the area is just the base times the average height. And like I said in one of the other videos, the nice thing about that is that formula actually works fine if the trapezoid happens to be a rectangle, which it possibly could. If the top were going completely horizontal, that would be a rectangle. And then the average height would just be either one of H1 or H2, and that would be the correct area formula for a rectangle. And then the other extreme case would be if like your H1 was 0, then that's really a triangle, and the formula is still right for that. So really, this formula is a nice one to know, because if one of your heights is 0, it becomes the area of a triangle, and if your heights are equal, then it becomes the area of a rectangle. So it actually works in all those cases. All right, that's neither here nor there. What I need to do is see where the trapezoids are in the picture. So let me use green so it shows up. Again, the main thing is, see, I'm doing T4, so I want 4 trapezoids, which means I need to break this into four strips. So I'm going to draw one in the middle, draw one there, draw one there. So I've got 4 equal strips. How wide are they? Well, the distance between these two things, 12 minus 4, is 8. So if I've broken it into 4 strips, that means each strip has to be width 2. So I can go back and label where these are. So it goes 4, 6, 8, 10, 12. So that seems labeled right. In this case, I do want those labels. Those are actually the points that I want to use. The midpoint rule is the one that has to use different points, but once I have this labeled, I do the points that are on the curve above those tick marks are exactly the points I want to use. And so the idea is, if you just literally connect the dots with a straight line, then each one of these is a little trapezoid with a flat top. Right, so each one becomes a trapezoid. And all I need to do is find the area of each of those trapezoids using this formula, and then add them together. So back over here, we get rid of some of this stuff so I can see it. All right, so back over here, I'm going to focus on the first trapezoid in that picture, the one on the left. The base of it is 2, and then I want times the average height. Well, the height on the left side, the height over here, is just the y-coordinate of that point right there. The y-coordinate of that point is f of its x-coordinate. So the y-coordinate of that dot is f of 4. The y-coordinate of that dot, that's the right-hand height of this first trapezoid. The height of that point is f of 6. Oops. So that would be base times the average height applied to the first trapezoid. If I do that for each trapezoid, looks like this. Notice that there's some redundant information in there. I get to use the f of 6 more than once and the f of 8 more than once. And so it's not crazy when you draw this picture to just label these dots, and that will make your life a little easier. So, oops, not 2. Sorry. So that first dot, for example, is 4, comma, and then I've got to plug in 4 for x. So f of 4 is 2 times 64. So that's the first dot. The second dot is going to be 6 times, oh God help me, 432, like that. The advantage of that is that when you're doing this calculation now, when you need f of 6, it's right there, and then when you need f of 6 again, it's right there. You don't have to plug it in. You don't plug 6 in here twice. So, so keeping a little notation about what you're labeling here actually helps over here. But anyway, this is going to be the answer. Like I said, doing it with 8 subintervals makes this pretty tedious, and so I would recommend using an app for that. But for a picture that has 2 or 1, 2, 3, 4 subintervals, I don't think any problem I would ask has more than 4. you should be able to draw this picture and write down this formula from that picture to show that you understand how the geometry of trapezoids is giving us an approximation to the integral.